In this lecture, we gave an overview of text mining and analytics. First, let's define the term text mining and the term text analytics. The title of this course is called Text Mining and Analytics. But the two terms, text mining and text analytics, are actually roughly the same. So we are not going to really distinguish them, and we're going to use them interchangeably. But the reason why we have chosen to use both terms in the title is because there is also some subtle difference if you look at the two phrases literally. Mining emphasizes more on the process, so it gives us an algorithmic view of the problem. Analytics, on the other hand, emphasizes more on the result or having a problem in mind. We are going to look at the text data to help us solve a problem. But again, as I said, we can treat the two terms roughly the same, and I think in the literature you probably will find the same. So we're not going to really distinguish them in the course. Both text mining and text analytics mean that we want to turn text data into high quality information or actionable knowledge. So in both cases, we have the problem of dealing with a lot of text data, and we hope to turn these text data into something more useful to us than the raw text data. And here we distinguish two different results. One is high quality information. The other is actionable knowledge. Now, sometimes the boundary between the two is not so clear. But I also want to say a little bit about these two different angles of the result of text mining. In the case of high quality information, we refer to more concise information about the topic, which might be much easier for humans to digest than the raw text data. For example, you might face a lot of reviews of a product. A more concise form of the information would be a very concise summary of the major opinions about the features of the product, positive about the, let's say, battery life of a laptop. Now, this kind of results are very useful to help people digest text data. And so this is to minimize the human effort in consuming text data in some sense. The other kind of output is actionable knowledge. Here we emphasize the utility of the information or knowledge we discover from text data. It's actionable knowledge for some decision problem or some actions to take. For example, we might be able to determine which product is more appealing to us or a better choice for a shopping decision. Now, such an outcome could be called actionable knowledge because a consumer can take the knowledge and make a decision and act on it. So in this case, text mining supplies knowledge for optimal decision making. But again, the two are not so clearly distinguished, so we don't necessarily have to make a distinction. Text mining is also related to text retrieval, which is an essential component in any text mining systems. Now, text retrieval refers to finding relevant information from a large amount of text data. So I've taught another separate MOOC on text retrieval and search engines, where we discussed various techniques for text retrieval. If you have taken that MOOC, you will find some overlap, and it will be useful to know the background of text retrieval for understanding some of the topics in text mining. But if you have not taken that MOOC, it's also fine, because in this MOOC on text mining and analytics, we're going to repeat some of the key concepts that are relevant for text mining. But at a high level, let me also explain the relation between text retrieval and text mining. Text retrieval is very useful for text mining in two ways. First, text retrieval can be a preprocessor for text mining, meaning that it can help us turn big text data into a relatively small amount of most relevant text data, which is often what's needed for solving a particular problem. And in this sense, text retrieval also helps minimize human effort. Text retrieval is also needed for knowledge provenance, and this roughly corresponds to the interpretation of text mining as turning text data into actionable knowledge. Once we find patterns in text data or actionable knowledge, we generally would have to verify the knowledge by looking at the original text data. So the users would have to have some text retrieval support to go back to the original text data to interpret the pattern or to better understand the knowledge or to verify whether the pattern is really reliable. So this is a high-level introduction to the concept of text mining and the relation between text mining and retrieval. Next, let's talk about text data as a special kind of data. Now, it's interesting to view text data as data generated by humans as subject sensors. So this slide shows an analogy between text data and non-text data, and between humans as subjective sensors and physical sensors such as a network sensor or thermometer. So in general, a sensor would monitor the real world in some way. It would sense some signal from the real world, and then it would report the signal as data in various forms. For example, a thermometer would watch the temperature of real world and then will report the temperature in a particular format. Similarly, a geosensor would sense the location and then report the location specification, for example, in the form of longitude value and latitude value. A network sensor would monitor network traffic or activities in the network and then report some digital format of data. Similarly, we can think of humans as subjective sensors that would observe the real world and from some perspective, and then humans would express what they have observed in the form of text data. So in this sense, human is actually a subjective sensor that would also sense what's happening in the world and then express what's observed in the form of data, in this case, text data. Now, looking at the text data in this way has the advantage of being able to integrate all kinds of data together, and that's indeed needed in most data mining problems. So here we are looking at the general problem of data mining. And in general, we would be dealing with a lot of data about our world that are related to a problem. And in general, we will be dealing with both non-text data and text data. And of course, the non-text data are usually produced by physical sensors. And those non-text data can be also of different formats. Numerical data, categorical or relational data, or multimedia data like video or speech. Right? So these non-text data are often very important in some problems. But text data is also very important, mostly because they contain a lot of semantic content, and they often contain knowledge about the users, especially preferences and opinions of users. Right? So, but by treating text data as the data observed from human sensors, we can treat all these data together in the same framework. So the data mining problem is basically to turn all the data into actionable knowledge that we can take advantage to change the real world, of course, for better. So this means the data mining problem is basically taking a lot of data as input and giving actionable knowledge as output. Inside the data mining module, you can also see we have a number of different kinds of mining algorithms. And this is because for different kinds of data, we generally need different algorithms for mining the data. For example, video data might require computer vision to understand the video content, and that would facilitate the more effective mining. And we also have a lot of general algorithms that are applicable to all kinds of data. And those algorithms, of course, are very useful. Although for a particular kind of data, we generally want to also develop special algorithms. So this course will cover specialized algorithms that are particularly useful for mining text data.